Okay, so I just did chapter 23, which is flux density. I think that's what it's called. Oh, no, I lied. I don't know why I wrote flux density. It's magnetic fields, obviously. Sorry. Okay, so, but one of the primary things to note here is how we define flux density, because seemingly it changes a little bit. So for the first question, it was to define flux density. Basically, every time I just kind of described it because I didn't have a set definition for flux density. So in the first question, it was force experienced by a wire when a current is running through it at 90 degrees to the magnetic field lines. Okay, but then later on we define it again as flux density times by, felt by, it said multiplied by, I think it's felt by the area normal to the field, so cos theta, basically, the area that is perpendicular to the field lines. For safety's sake, I think I'd just say both. Or put it to, if there is context, then apply it to that. But I think safety, just say both. Okay. Ask me for maximum uncertainty. Here I made a boo-boo because I just took, because we had a table of results here, and I just took the range of these results and halved it, which I'm still not sure if, let me check something, is half the range the percentage or absolute uncertainty? Half the range is the absolute uncertainty according to, I think, Save My Exams. Absolute uncertainty is range. Okay. It asked me for the maximum uncertainty, and I did that for that graph, but I don't think you should do that. I think I figured out now that that you only do that when you have when you're creating an average of results, when you have several readings for one result. Where it asks for the maximum uncertainty, you need to presume the maximum resolution, and then take that to the minimum reading, because obviously that's going to give you the largest fraction for uncertainty as a percentage, so you can get that largest value. Yeah, and then multiply it by the, I think it asks for percentage here, but for absolute you just multiply it by the figure that you compared it to, that smallest figure that gave you the largest uncertainty. Fine. I made a calculator error when calculating centripetal force, so don't do that. Should have figured that out by my gross error check. For the next part of the question, I got flux density is 10 to the minus 18, which is a little bit small. Right, talking about how effective, how it's flux dense. Okay, how the magnetic flux changes when something is rotated. So obviously we know that it is the change in effective area that causes that change, because F is built cos theta, basically. But I think adding a bit more detail, it's more useful. You should say that EMF or flux density actually. Does it ask for flux density, or does it ask for? Yeah, and also flux. That tends to 0 to when the wire is parallel to the magnetic field. Obviously it says 0 effective area, and then is dependent on cos theta. So I think there's just a few detail points I missed out that could be something if this was a 2 or 3 marker. Is that the end of that chapter? Okay, and obviously remembering there's acceleration, but no work is done, so there's a change in velocity, not speed, blah blah blah. When you have centrifugal forces, a lot of those come up in magnetic forces. Yeah. Oh yeah, I remember thinking this value for question 5 for field strength was very, very high because it was 3.28, but I guess that, I mean, it's right, so I guess that's what it was. So I guess gross error check from about, it should be less than 10 and maybe bigger than about 10 to the minus 3, roughly. Oh yeah, so when you change the changing the speed of when you rotate a coil through a magnetic field, obviously your maximum EMF is going to be twice the original value. I just wrote EMF will be doubled because the time taken is halved and then blah blah blah, but max EMF I think okay, and then for CIII why am I so confused? Okay, so it was asking for some interpretation of this graph. Oh yes. And so I just wrote the variation in EMF is proportional and equal to the negative change in flux linkage. I think that was not a very clear answer, and I wouldn't have got anything for that. I knew what I meant, but I don't think an examiner would. So I think what you should do is do what they said in this mark scheme. So address when the maximum EMF is compared to the time on the given graph for flux linkage, yeah. Or you can say that it is pi over 2 out of phase, and then follows a sine curve instead, because obviously that's, it's the same as if you shift it. It will. I don't have pen and paper, but you know what I mean. Yeah. When did I get that voltage? Yeah. Okay. Nice. Big smile. We can do this.